time. Now, Unit C is really short. It's actually only 4 lessons. But we're going to break up these lessons into multiple parts because we're going to make sure that we're getting good at one part before we move on to the other. So, first off, we need our system of equation. What is a system of equations?
I don't know. A system of equations?
It would imply that how many equations are we working with?
Ooh, that's clever.
2 or more. So a system of equations means that we are going to work with 2 or more equations Do you need a pencil? And work with 2 or more equations Work with 2 or more equations at the same time. Because you're making a mess. You're making a mess. Take to your notes. Do the expected behavior of notes.
Another way to think about it is system. System usually means there's a lot of moving parts in it.
Can I just do my work?
For example, the school system. It's not just our class. There's multiple classes and even the front office and everything that's going on.
You're a
at the
9th grader.
same
You
time
can do
as
this.
well. So for this one, it's multiple equation that's going to happen at the same time.
That's what we're going to be working this whole time, is to find a solution to the system. Okay, a solution is always going to look like an ordered pair, x, y. That's how we're going to be working with it in this class.
No. Hey, Miss, when are we just going to do like problems?
I know, you sit right here. All right, and this is going to be values for the variables. That make all equations true. Values for the variables that make all equations true. Remember we talked a little bit about that true equation that was way back in A3. What were our other options for equations? True, false, or
True.
take a look back if you need to. Go back to A3. A3. It's way at the beginning of the year. True, false, or open. Good. And true means what? What makes an equation true? It makes a number, and the other side makes a number. And what do we know about both those numbers?
That could be the same.
They're the same. Good, because it's equal. Yeah. All right, so we're going to start off with our first examples. Are going to say, is it a solution?
Just check. Can't have you watching videos while you're working.
All right, so for example number 1.
Oh, shoot, we're getting into the examples already. I haven't really done anything.
Okay. We have y equals 2x minus 3. That's one equation. Remember, we're working with 2 equations. When we do a system, we always stack them. So the next one is going to be right underneath it. 4x plus y equals 3. And I want to know, is the solution 2, 1? Is that a solution to the system?
Yes.
How do you know?
Because it's so small, so put it.
When I input 2, do I always get 1 as an output?
Yes.
Let's try it out. So we're going to do it with 2 of the equations. So I'm going to start with that y equals 2x minus 3. And I'm going to put in the different parts there that I have in this ordered pair. What's going to go in for my y? 1. Because up here I have my x and I have my y. So for the y, we're going to put in 1 equals 2. Now instead of x, what number is going to go in for the x? Yeah, parenthesis what? 2. Good. Our x is 2 there. Minus 3. And we're going to see if that is true, false, or open. It can't be open because we have numbers. So we need to see if it's true or false. So I'm going to go back to my order of operations. Am I going to multiply first or subtract? Multiply. Good. What's 2 times 2? 4. So now I have 4 minus 3. Four minus 3 is 1.
Yeah.
So did this one work? 1 equals 1?
Yeah, but maybe the other one won't work.
Right. So does that mean it works for both equations?
No.
No. So I'm going to do this little dashed line showing that now I'm going to check the other equation. So for my other equation, I'm going to write that 4x plus y equals 3.
Maybe not.
And we want to see, does that same xy, does that solution work for both?
No. No.
So far it works for one of them. We need to check the other. So I'm going to replace that x and the y with our ordered pair here, xy. So I'm going to do 4 times, what's my x? 2 plus, what's my y? 1. And I want to know, does that equal 3?
1 plus 1 equals 5.
Working ahead on us. Good. All right, what is 4 times 2? 8. And we have that plus 1.
That's not true.
8 plus 1 is 9. Does 9 equal 3?
No.
No. So we put that little slash saying, nope, didn't work. So if I'm asking if this is a solution to the system, I'm saying, does it work for all the problems in that system?
No.
If I have a yes and a no, together that's going to make a...
Maybe. Possibly.
Not open. Is it going to be...
Undefined.
Do they both work? Does it work for both equations? No. So overall, my answer is no. When I have a yes and a no, and I combine them, my overall answer is
Maybe.
no.
Why?
They both have to work.
Oh, see, I knew that.
All right, let's try one more of this. Number 2. If you want to work ahead on this one, it would be a good idea. This would be a good one to work ahead on.
I was just testing you to see if you knew where you were.
All right, number 2, we have the solution. We're going to use the same equations. Y equals 2x minus 3. And 4x plus y equals 3. So same equations, but we're going to try a different solution.
Whoa, what do you mean?
We're going to try 1, -1. I want to know, is 1, -1 a solution to this system?
Nope.
All right, so let's start with our first equation. Y equals 2x minus 3. We're going to put in the x and the y that we have in our solution here. So what's going to go in for my y? Which part of this is the y? Good, the -1, because an ordered pair always goes what first? X and then y. Good. So when we see that y, we're going to put in -1 equals 2. What's our x? 1 minus 3.
Wait, hold on. That's like -1.
All right, what is 2 times 1?
2.
2, good. So 2 times 1 is 2. One step at a time, Q. 2. And then we bring down that -3 because we're following our order of operations. If I start at 2 and I go backwards 3, where do I end up at?
4.
Try it again, Jordan. 2 minus 3. -1. So did it make it true? Is -1 equal to -1?
Yeah.
Yep.
It's okay.
Okay, now let's try the other equation, because for a system it has to work for both. So for my other equation, we have that 4x plus y equals 3. So I'm going to start with 4, parenthesis, what's my x? 1. Plus -1, good, equals 3.
Miss, you're going too fast.
Okay, give me a second.
Alright, bro, you gotta stop your hating.
Joel, Q. Hey, Q, stop. Didn't need to comment on it. We're good. Alright, what is 4 times 1? 4. Plus -1. Oh, damn. If I start at 4 and I go backwards 1. Positive or negative? Positive. So is that true or false? True. So did it work?
Yes.
Yes. It works. They're equal. So is 1, -1 a solution if they works for both? Does it work for the system? Yes. Has to both be yes in order for it to work for all of it, for a yes. All right, I'm going to flip the page because I'm running out of space here. We're going to now move on to graphing. It's kind of a lot today, I know, because it's the first lesson. Usually the first lesson is a lot.
Why?
Why? Because it's just a lot of new information.
Great.
All right, so I'm going to flip the page, and I'm going to take out 2 colored pencils and a ruler. If you would like to take out 2 colored pencils, ruler, and you'll need a glue in just a moment. I'm going to use red and blue. Joel. Be nice with people. All right, so now we're going to be on the next page. I'm going to the next page. Go to a new page. We're going to be graphing systems now.
We just got 2 colored pencils, you said?
Yep, 2 colored pencils. If you want your ruler and then a glue. Alright, I'm going to use blue and red, but you can use 2 colors. We're not going to be using it too much, so just do it the way you need to. Alright, for our first one, if I have a line going this direction, that means all the points on that line are solutions. So if I have another line that goes the other direction,
Wait, is that graphing system?
yep, graphing systems. All right, how many points do those 2 lines have in common? 1. Where is the point that they have in common? Yeah, where they cross. So where they cross in the middle there, this is one solution. So we're going to have one answer. Okay? So lines can cross once. They can also look like this, where I have one going this direction. And then I have one kind of going in that same direction. Does anyone remember, what do we call those lines that go in this? Parallel. Good. That's what we're doing in geometry right now, is parallel lines.
I call it parallel.
And how many points do these two lines have in common? None. They're never going to cross. They're running side by side forever and ever and ever. So we say that this is no real solutions.
At least like boyfriend and girlfriend.
I guess. That's one way to look at it. No real solutions.
Yeah, because like they're always together.
It's never going to cross. Now, the reason we put in that word real is because sometimes there's these things called imaginary numbers that happen.
Great.
But we're not going to learn about imaginary numbers this year. We're just going to keep it as that we're working with numbers that we know of.
Amazing.
There's a number out there that you haven't even thought of yet. Isn't that crazy? You don't even know. It's an imaginary number. All right, the other one we have is if I have a line. It can be any line.
I bet there's something called as a tillion.
Now, sometimes lines dress up as other lines. It's kind of like if you dress up for Halloween. You might look like someone else, but really you're the same thing. So sometimes these lines overlap. They touch in all the points.
Whoa.
So it's kind of like there's one on top of the other. They're really the same line. So how many points do these two lines have in common? All of them. Ishmael, put your computer away, thanks. All of them. So how many points is that if it's all of them? 7? Well, the lines have arrows. So that means they go on forever and ever and ever. What word do we have that goes on forever and ever and ever? Infinity. So infinite is the word we use. Infinite means that there's an uncountable amount. It keeps going on and on and on and on forever and ever. So infinite
You
solutions.
spelled infinite wrong.
Well, we're not doing infinity. It's infinite. It's a little different.
Yeah, you spelled it wrong.
That's how you spell infinite. If you're doing infinity, that would be different.
Infinite is spelled with an M. It's a silent.
Okay.
Literature.
All right, you're going to be getting this sheet of paper. You're going to glue this in on kind of the side. Leave a little space here for your work. Make sure that you have it in on the right spot. You should see the Y on the top. We're going to do 2 examples here. So go ahead and glue that in. There should be at least 2 glue sticks in your bin.
I'm so hog champ.
Well, right now
This is so saucy vodka. This is so vodka ammonia. This is so.
Okay. Start by writing down the notes first. All right, so start by gluing those in. Pass that glue around so everyone gets a chance to get it.
What if I want to glue it to that side?
Well, you can glue it to the other side, but you just want to have room for work.
God, what have we done to these glues? It's like blues clues.
All right, we're going to be doing example 3, so I'll give you about 30 more seconds to get that glued in.
Hold on, gang. Whoa, you must not know what I've done. Can I do it on the other side?
Yeah, as long as you have space for work.
That's right.
All right, for our first one here, example number 3, we have 2 lines. We're going to have y equals 1/3 x plus 4. And y equals negative 5/3 x minus 2. So to find our solution here, we're going to graph those two lines. So I'm going to start with making one of them blue. I'm going to do this top one. If you don't want to do them in color, maybe box one and then, I don't know, they're going to both be on the same graph. So doing it in color is kind of nice. All right, so I'm going to start with this one, this y equals 1/3 x plus 4. When we graph a line, what are we going to start with figuring out? What kind of form is this one in? Is this standard form, slope-intercept form, or point-slope form? Slope-intercept form are y equals mx plus b. That's pretty zoomed in. I can't really do more because I have to graph it. All right, what is my m? 1/3, 1/3. And what is my b? 4. So if I graph this line, this blue line, I'm going to go to my graph paper. Where am I going to start? Do I start with the 1/3 or the 4?
1/3.
Where am I going to put 1/3? Yep, I start with the 4. Remember, 4 is our y-intercept. So on my y-axis, I'm going to start with 4. So I'm going to go up, down, left, or right. Up 4. 1, 2, 3, 4. And we put a point there.
Remember, M is our rise and run. If we don't have a point, we can't really do a rise and run.
What?
We have to move from somewhere. We have to have a starting point. All right, so now if I have 1/3, 1 tells us to go up 1. And which way is over 3? To the right, it's positive. So from this point, I'm going to take my pencil, I'm going to go up 1, and to the right, 1, 2, 3. Okay, I'm going to do that again. From our point, we go up 1 jump, 3 jumps to the right. 1, 2, 3. We could do it again. Go up 1, over 1, 2, 3, and you should be right in that corner. If I wanted to go in the other direction, instead of going up and to the right, which way would I go?
I don't know.
I could go down 1, and then which direction? Left to the 3. 1, 2, 3.
Smarty pants.
Down and to the left. 1, 2, 3. All right, if you got that ruler out and you want to use it, otherwise if you're going to just eyeball it, it just might not be perfect.
I like it when it's bold. You know what I'm saying?
All right, next up we have our other line. Do the notes with us. Yep, expected behavior is doing notes. We did a lot in pencil first. Do it in pencil and then we can give you the colored one to go over it. Alright, so I'm going to do this one in red. I'm going to show my work over here. So I have y equals negative 5/3 x minus 2. So I'm thinking, what is my m, what is my slope, and what is my y-intercept, my b? Think about that first, Q. Good. Which one is my b? Negative 2. Good. Okay, and then my m, negative 5 over 3. Okay, and I'm going to do this in red. If you're not using colors, you can just use your colored or your regular pencil. That's fine. It's just going to be hard to tell which line is which. I already see like Muhammad worked ahead. He graphed it. That's awesome. Crushed it. Where am I going to start with my M and my B? Do I begin with M or do I begin with B? Begin with B, negative 2. So from my origin, I'm going to go down 1, 2, make a point. Now from that point, we do our movement, our M. So our movement says negative 5 over 3. So I go down 5. 1, 2, 3, 4. Can't go down 5.
So you're up then, right?
So I'm going to go up 5. 1, 2, 3, 4, 5. But which direction do I need to go to make it a negative slope? It's got to be a slide.
Left.
Left. Good. 1, 2, 3. I saw a couple people do it with their hand motion.
Oh, wait, we're doing it in the same problem as the blue one?
Yep, because we got to see what the solution is. Where do they both have a point in common?
See. Okay.
All right, so does this have one solution, no real solutions, or infinite solutions?
Infinite solutions. One.
One. How many points do they cross?
One.
Just one. Okay. Oh, Jordan, not what glue's for. Please don't glue my ruler. Jordan, stop. Expected behavior, dude. All right, so for my solution, what is the x and the y that go with that graph? Where do they cross?
Negative 3 or 3.
Good, I want to do my x first, so left 3,
Negative 3.
and then up 3. So negative 3, 3. My x and my y.
It's gonna be a 3.
All right, I wrote kind of big on that one. I wasn't supposed to write that big. So number 4 is going to be down here. But we're going to use this next graph. Okay, that part where they cross, that is our solution. If you need to do like a little arrow there, to show that that's what we were looking at for that negative 3, 3. That's our answer. No, because it would just be the same graph. How would we do that, right?
So what if the points don't cross at all?
Then there's no solutions. Because then they're parallel. All right, number 4. Last one here. We have negative 10x minus 8y equals 24. And y equals negative 5/4 x minus 3. So we have two equations here. We got to graph them. Is our job in this situation is to graph and see how many times they intersect or touch. What's this first equation? What form is that one in? Is that in slope-intercept form, point-slope form, or standard form? Negative 10x minus 8y equals 24. I think somebody said it. We had conflicting answers. Standard form. Good, it's at ax plus by equals c. For standard form, can we really go straight to the graph from there? No. We have to solve that so that it's for y equals. What about this bottom one? Y equals negative 5/4 x minus 3? Yeah, that one's really nice. Let's start with that one then. I'm going to do that red one first. Just because it's easy. We'll start with the easy one. So for this bottom one, what is my m?
Negative 5 over 4.
Good, negative 5/4. And what is my b?
3. Negative 3.
Negative 3. That one's in our slope-intercept form. We can find our M and our B. Today's a really good day. If you had a tough time on that Unit B test, this should be kind of good review, good relearning. All right, so I'm going to start with my B, my -3. So from our origin, we're going to go down 1, 2, 3. Now we're going to run into that same problem we ran into last time. Can I go down 5? Marcos, put it by your phone. Nope, I can't go down 5.
Instead you gotta go up 5, 2, 3, right?
So we'll go up 5. 1, 2, 3, 4, 5. And I need to run 4. But it needs to be a negative. It needs to go downhill. So which direction is going to be downhill? To the left or to the right?
Left.
To the left. 1, 2, 3, 4. And we can just double check it. Make sure, is that a negative slope? Is it a slide?
Yes, it is.
Yep. It's negative. It's a slide. All right, now, this top one, this negative 10x minus 8, y equals 24. Yeah, we got to solve this one for y. So we're going to write this one, rewrite it down here. We have negative 10x minus 8y equals 24. And we have to solve this for y. We want it to look like y equals mx plus b so we can graph it. So I'm trying to get the y by itself. That's my goal. With that y, I have an 8. They're best friends. They're hanging out. Mejor amigos. Right? So I need to get rid of this x first. How am I going to get rid of a negative 10x? Good, I'm going to add 10x. And if I do it to one side, both sides. In a moment, yep.
Why not just a single side?
Because then it doesn't stay equal. Whatever you do to one side, you have to do to the other side. That's how things stay equal. All right, this negative 8y drops down. Can I combine a 24 and 10x? Cannot. So we have 10x plus 24. I'm going to just put that x first because in slope-intercept form we want mx plus b. We want the mx first. So I just switched it around so the 10x comes first. Okay? Now, does it look like y equals mx plus b?
Yeah.
Is it just a y?
Oh no, you got to divide by -8.
Yep, we got to divide by -8. Good. So I divide by -8. And when we divide, we're going to divide everything by -8. So I'm going to divide the 10 by -8 and the 24 by -8. Everything by -8. So what's -8 divided by -8? Not. What'd you say, Dane? 1. 1 y is the same thing as just y.
Just why?
Exactly. All right, if I do 10 divided by -8. Oh, I think you did it backwards. 10 divided by -8. 10 first. Okay, we don't want a decimal, though, because it's our rise and our run, so we wanted a fraction. And it simplifies to -5 over 4. How did they go from 10 over -8 to -5 over 4?
No idea.
Simplified. Good. What do you divide both 10 and 8 by to get 5 over 4?
4.
2. 10 divided by 2 is 5. 8 divided by 2 is 4. We don't like that negative on the bottom, so it just goes to the side. -5 over 4 x plus.
3.
It's okay to use Desmos. 24 divided by -8, -3. All right, so this is the same as that blue line that we started with. We just switched it around, so now it's easier to graph. So what is my M?
Negative 5 over 4.
-5/4.
And B is negative 3.
And B is -3. Joel, you're missing this whole problem, dude.
So it's going to be the same.
So if I start at -3, I go down 1, 2, 3.
I'm just going to put it up.
Now can I go down 5 and over 4?
No, it's going to be up there.
Can I go up 5? 1, 2, 3, 4, 5.
No, over 3.
I think 4.
It says 3.
But our slope is -5 over 4.
Yeah, you're right.
So are we going to go to the left or to the right 4 to make it as negative? Left 4. 1, 2, 3. Oh.
Same equation.
Oh, yeah. Look back at what we have. If you look at this blue and this red, are they the same?
Yeah.
Yeah, just this one says plus -3. This is -3. Same thing. So does this one have one solution, no solutions, or infinite solutions?
Too many solutions.
So many, in fact, that there's infinite. So our answer, when it says what's our solution, is infinite solutions.
How do I get that right without reading the calculations?
Okay, shh. Cue. All right, infinite solutions. It's going to go on and on forever and ever. They're actually the same line. They just looked different when we started. All right, there is a